Hello everybody, welcome to this webinar about good programming practice. I'm just going to tell you a bit about myself. I started programming SAS in 1996 and have experience with both pharmaceutical companies and CROs, and I've also been a contractor as well as a permanent member of staff, and as Louise mentioned, I'm currently the programming manager at Veramed, and I've been at Veramed for 2 years now. So I'm very happy to be with you here today to tell you more about good programming practices and how they can benefit you and those that you work for. My assumption is that you are either an individual programmer looking for inspiration to improve your own practices, or maybe to improve your company good programming practices, or maybe you're just curious about Veramed's good programming practices. We are very happy to share our good programming practice with you, and you can download it through our website. And whilst I will cover some of the program practices described in the Veramed guide, this will also be a bit about why having a guide is a good idea, and why programmers should be motivated to follow it, as well as a look at some of the practices mentioned in the guide. So why have a good programming practice? So the purpose of a good programming practice guidance really isn't to create a set of rules that a programmer considers a rod for their own back. What we want is it to be guidance, as in practical help for programmers once they come to the realization that the code that they create is actually a product, and it is a product that not only needs to work, but it needs to work efficiently, and it needs to be understandable, and it needs to be readable, and it needs to be reusable. And many of the objections that I've heard over my years of experience are based on the idea that as long as the code works, then who cares how it does it? But we reuse programs more and more. And with the increased use of CDIS standards, the opportunity to reuse programs has also increased. So it doesn't matter if you work for a CRO where your company is delivered to your client, or if you work for a pharmaceutical company, your code is a product and it may well be reused or amended. So in short, the purpose of a good programming practice is to end up with a product that is well structured, well documented, easy to read, easy to maintain, and is consistent. So creating a good programming practice, for us, the starting point of Veramed's good programming practice was Fuse. And if you are unfamiliar with Fuse, I recommend you visit the Fuse website. It's a not-for-profit organisation that has lots of material for programmers in the pharmaceutical industry. And Fuse has continuously collected opinions and contributions to develop its good programming practice, and it's recognised industry-wide. We felt that as a starting point it gave us a really good solid base, but of course we wanted to add to it, so hence we have sections called Veramed specific guidance in our GPP. And if you're interested in developing your own GPP, you may wish to adopt a similar approach. So the key to having a good programming practice that programmers want to adhere to is having guidance that's based on reason and having the input of the experience of as many willing people as possible. Having rules that are ultra specific for no reason other than personal preference is not a great way to get programmers to buy into it. So today I'm going to cover a few topics. I'm not going to go through, I'm going to go through some of the guidance in our document, but it will mostly be quite high level, and I won't be covering every single detail in the document because that won't be particularly interesting for you. But there will be an opportunity at the end for people to ask questions, and I'm happy to answer questions about the GPP if you've already downloaded it and reviewed it. So the first topic is getting started with a new project. So one of the purposes one of the purposes of study familiarization is to improve efficiency and quality. I'm so sorry, I feel like my slides have got out of order. Let me just pause. Yes, sorry. So one of the purposes of study familiarisation is to help improve efficiency and quality, and study familiarisation isn't always included in good programming practice, but it is good practice for a programmer to understand certain elements of the study, as this can lead to better self-checking of work and better QC. Usually a programmer will become familiar with study documents, some of which are listed here. So we've got things like the clinical study protocol, which outlines the study, and statistical sections are usually of relevance to us. CRFs, annotated CRF, so we can understand where the data comes from, how it's collected, where it's stored, the analysis plan to see what data is reported and how. Analysis dataset specifications, table shells, publications if available. We want to check against what's already, what results are already available, and similarly for the previous clinical study reports, just to check if there are already available results. And all of these will contribute to a programmer's understanding and hopefully prompt them to ask questions if there are any ambiguities. In addition, having an idea of the big picture can also have benefits. For example, programmers are encouraged to ask questions if they have awareness of things like some of the items in this list, which can help with spotting issues earlier. So things like the objectives of the study and how many patients are enrolled and randomized and treated, understanding the schedule of events, when the screening, run-in periods, treatment periods, how many treatments, when they are taken, what is the primary endpoint, when and where is this data collected, timelines for a trial, when is the database lock, when should the top-line results be ready, and the current status of the study. So all of these things can really contribute to a programmer's idea of the big picture, and I really encourage communication across functions in teams, and more familiarisation really does mean greatly likelihood of picking up issues early, which is more efficient. So moving on to things to check before you start programming. If you work for a pharmaceutical company or consistently for the same client, a lot of the things on this list don't change. However, for some programmers, these change with every study that they work on. So familiarizing with the system and company-specific programming standards, all of these types of things can change a lot, but one of them, the most common one that we tend to focus on, probably most of us focus on, is checking for reusable code and macros. And if programmers are committed to programming using good practices, then we're more confident about reusing code from other studies, and it can save us a lot of time and effort. So moving on to programming conventions, and not surprisingly this takes up the majority of our good programming practice guidance document. It would be quite a long process for me to go through every item in it, and so this section is actually quite high level, but I will go through some examples. So firstly, let's look at a few important elements. So firstly, I'll just mention here that we have actually specified the language to be used within our header boxes and comments in our good programming practice, which is the usual business language, which is English. And we have also included a section on header boxes, and header boxes are really important for identifying programs, and they are useful for documenting revision history. And it's a really good idea to create a standard, which at Veramed all our programs have access to the template, so there's no excuse for not using it. And it immediately gives programs a consistent appearance. So you can specify in your good programming practice which elements are mandatory, and you can see here from our header box what we've decided on. So this first point on commenting your code, comment as if the person reading is new to the study, pretty much says it all, because it's not about stating the obvious. You really need to explain why you're doing something. And if you've ever come back to complicated programs that you've written and you've had to update it when you haven't commented well, usually this is your learning point, and you learn the lesson when you get yourself tangled up. So yeah, and familiarizing yourself with different methods of commenting is important if you want to avoid issues with code falling over later. For example, if you add in further comments or comment out code, it's possible that your program will fall over if you haven't used the appropriate comment in the appropriate place. And of course, final programs ideally shouldn't have any comment out code in them. And consistency of style is important so that the code remains readable. We mentioned punctuation, and punctuation may cause issues elsewhere, so it's better to actually have bad English, bad punctuation than bad code, because the chances are that your comments really will be understood. And remember to update comments when code is being updated, so there's that continued understanding of the program. So moving on to naming conventions, the conventions are for things like the variable names and macro variable names and macro program names, dataset names, format names, and output program names and output names. So really, in a nutshell, it's about having a standard, and we specify in our good programming practice what that standard is, and we also say that the name should be meaningful, short, unique, and where possible descriptive. So our standard, just as an example, is that maybe for a table program we'd have a prefix of T underscore, and a listing program L underscore, that type of thing. And for coding conventions, these are just a sample of some of the conventions in the guide, but the focus is on readability and reusability, and I often feel like I'm repeating myself with these terms, but it is the underlying base of good programming practice, and it comes back to the same points: readability and reusability. So I've written some examples here, just things like consistent indentation and always using data equals and ending off data steps with run and quit. We always ask our programmers to consider structure as well, but we'll go on and have a look at an example. So this is an example of a hard to understand program, and you can note the inconsistent indentation. It's quite difficult to read. There's long dataset names here, long variable names, uppercase variable names. It covers the issue of overwriting of work datasets, and there's no comments. And some additional comments on this is that to comply with our GPP, this bit of code should be checking for missing values prior to calculating the variable mon underscore SDD. Not all the data steps are ending with a run statement. It's not very well structured. It's missing some blank lines. And you'll also notice at the end there's a proc format, and we really don't recommend doing that because we suggest that they be placed in a separate format program which creates a catalogue that's usually in the same library as the analysis data sets. So this is a little more straightforward example. One of the things that we talk about in our good programming practice is that all non-executable statements should come before or directly after the set and merge statement and before other executable statements. So these two bits of code is the correct way of doing it, and this is to ensure that those statements don't get lost in the code lower down, and particularly when you've got a very long data step. And this is our last example here in this section. So we recommend capturing unexpected values for when we're doing some if-then else processing and making sure that we've got the else or otherwise statements, and this is an example here. And examples really are a great way to help with the education of good programming practices, particularly for more junior team members. And it might be worth considering creating a separate examples document for programmers so that you can get your conventions across to them. So just to round this section off, this is our recommendation, really. Keeping everything simple is only going to aid readability and understanding of programs, and sometimes we think there must be a super fancy way of doing something that involves long SQL procedures or nested loops or something like that, but actually considering somebody else using your program might prompt you to keep things more simple. And as I said, I would be repeating myself, and I really am. You know, it's because reusability, readability are just so important. And I also mentioned efficiency here, and really efficiency could be a presentation on its own, but it is a part of our good programming practice, and it is detailed in the programming convention section. And the final product is our deliverable, and using the programming convention advice helps with the production of good, efficient code. So moving on to checking your log. So with log checking, we often ask this as an interview question. I think every interview I've ever been to has had a question about what do you check in your log. So I guess we should actually all know the answer. But that said, not everyone is in the habit of checking their log, and we all know about errors and warnings. But actually, I do think it's reasonable to ask people to be familiar to what we refer to as undesirable messages in the log. And these are just a selection here on the slide. A lot of these notes allude to code written by a programmer who doesn't appear to be familiar with the data that they're working with. So it is desirable that code is appropriate for its data type. And let's take a quick look at portability. So portability is something that a CRO may give more consideration to than a pharma company. However, most organizations now are working across multiple platforms and commonly combining Windows and Unix environments. And there can actually be many occasions where code will work on one platform and not on another. So we should give consideration to portability. And it's more than just working across multi-platform environments. It's also about making programs easy to be used across projects. And here on this side, we're just a couple of suggestions that address some of the common impediments to portability that we considered in our good programming practice. So on here with the rounding of newly created variables. So for example, a 64-bit operating system to a 32-bit system. And we might give careful consideration when we're doing this and round at the limit of precision so it doesn't affect results. And the second one mentions explicitly defining file paths like in your libname and file name and %include statements, and so anything that is requiring platform specific syntax such as the forward or backslash. So hard coding. This is another example of a technical question that's often asked at interview, and it's certainly something that should be addressed in a good programming practice. And the general consensus is always don't do it, but there can be rare exceptions, and you should decide how those should be addressed. And this is our specific guidance. We decided that we want a message to be written to the log and to make it very clear in the code comments. So defensive programming is something we encourage programmers to do in an effort to get them to anticipate future changes in the data that might influence the coding algorithms, and ideally programs should be written in such a way that they will continue to work correctly in the case of new or unexpected data values which didn't time that code was created. So we often develop our analysis data sets and table programs in quite an early stage. Sometimes we do it on test data. So we need to have the study familiarity. We need to know what's going on with the CRF, and we need to adopt defensive programming techniques so that there's much less rework when we've actually got closer to database lock data. So we're coming towards the end of this good programming practice, but I just want to talk a few about the do's and don'ts that we have. We put together this list to put into a laminated handout that we give to all our programs, which is quite a good idea to have a sort of condensed version of a good programming practice easily to hand for programmers. And so I'll just quickly run through them. So do use a program header, and this I already mentioned, and we've looked at the Veramed programming header, and it's really important, and equally important is to not forget to fill it in. And I tell programmers that it is really important to fill out their header, because auditors might not be able to read SAS code, but they can read a header. And if the header isn't correct, they might think that other things aren't correct as well. So do comment your code. We spoke about the importance of commenting code and how important it is to say what the code is why the code is doing what it's doing, and explain elements of the code that need explaining rather than just saying what the code is doing. Do use unique and informative dataset names, and don't use inconsistent or seemingly random names. Do use one statement per line, and indent consistently and program defensively. And don't program around data issues. And when I first joined the industry, this was a quite often discussed topic. It was an ongoing battle between programming and data management as to how much we would program around, and I think generally the consensus is you don't program around anything. Everything goes back to data management to resolve, and that is clear in our good programming practice. Do check your log, and don't ignore the notes that indicate potential issues in the log. So in conclusion, I just want to say that this webinar has been an opportunity for us to share our good programming practice with anybody who is interested, and I hope that you've actually understood the benefits of having a good programming practice, and that if you don't have one, you're inspired to create one. Partly it's about giving guidance on several aspects of programming a deliverable as well as the actual coding, and providing a framework for programmers is a good way of encouraging consistency in deliverables, and it helps ensure a good quality product. So it's not about imposing a personal style upon programmers, but it's about giving logical guidance that programmers will buy into. And hopefully when a programmer appreciates that the style in which they code really does give an impression about how good a programmer they are, they will buy into the importance of using good programming practice guidance. So as I previously mentioned, everybody is welcome to download a copy through the Veramed website, and thank you very much for joining me today. I think we will now have some questions.
Thanks, Diana. So if you do want to ask Diana any questions, there's a questions box on the toolbar in your GoToWebinar program that you have open right now that you're watching us on. So we do have a question that came in whilst you were talking, Diana. People who are preparing for SAS programming at home, do you have an idea of how many hours practice they may require weekly?
Oh, sorry, say that again. I'm sorry, I'm not quite sure I understood that. Say that.
I think the sentiment was that for people who are learning SAS programming at home, how many hours practice would you recommend per week? How long a piece of string?
Per week. I don't know. I suppose it depends on the individual. I think it's not like going to the gym and trying to get your muscles in shape, although I suppose it is a bit like getting your brain muscles in shape. I think your good programming practices evolve with experience. So you start off at one point, and as you get experience of coding, and it's that live experience of having to go back and change things and having comments from QC and learning to self-check. All of those things do come with experience. So I think when you're learning, you can only really take the guidance that you've got and try to remember to apply it. I think it's when it's in real world situations that you really, some of it gets, the message gets hammered home with some of it.
Definitely. Okay, there aren't any further questions at the moment. Diana has provided her email address on that last slide, so if you do have anything pop into your head that you'd like to put to her about good programming practice, you're welcome to email her. So I think we'll close there. Thanks, Diana, for your time this afternoon, and thanks everybody else for attending.